Hey, hi everyone, this is Vivek and welcome to the second part of the day 3. And in this particular video, we're going to talk about another form. So let's quickly get into what we have been talking about. So what we have been learning in the last two videos, or last video is the form 2, and last to last videos on the previous day were about building the mental picture for form 1. This is what we have currently learned, that in form 1 we kind of have this index and we are kind of solving it from over here till the end. We have some property x that we say for the previous things. It can be multiple properties. I'm just keeping it as an x over here, and for this particular index we decide what to do. That decides the transition, and like we return what is y for the index this in the previous x, right? If previous x is there, what is the answer in the range index to n? That's the whole setup. For form 2 we have some sort of chain that gets built up, or some sort of path that builds up, and we contain some aggregate x for the thing. What is the best y starting or ending at a particular index is what we do. I generally use ending, you can use starting as well, it's perfectly the similar thing. Okay, now let's unlock one more form. So the third form that we can unlock is something called as multi-sequence DP or multi-array DP, you can think of that way as well, where we have multiple different arrays or strings or things like that given, and we want to do something with that. Okay, so what we do in that case is we keep two different pointers or two different levels, okay, I and j over here, and we solve the problem accordingly. So these kind of problems generally happen to have more of interaction between elements of two different sequences, and you need to compute things accordingly. So what we do in these cases is we keep first level over here at a particular index, second level over here at the particular index, and then some other information that you might keep for the previous like elements that you have decided or things like that, maybe some x over here, right? And that's how the states are formed, and the meaning is going to be whatever is asked. I mean, something, whatever is asked in the problem, okay, or best or count, whatever you want to do. Let's say count of whatever is asked in the problem in, let's say let's call this array A and let's call this array B. I mean, strings are also arrays, that's perfectly fine. In A of I till n, let's say this is of size n, this is of size m, and B of j till m. Let's say these are two different sized arrays. So if this much of the portion of array B is left and this much portion of array A is left, what is the best thing that we can get for whatever is asked in the problem? This is generally the form 3. Okay, note that when I'm saying that these are best asked in the problem, this is in that class of 90% of the problems where the meaning comes directly from what is asked in the problem. But in case it's not that way, we sometimes might change the meaning of the definitions or the DP as well. But again, the main idea is this level that we keep in both the things, and they both are traversing in separate ways into the two arrays given. This is called multi-sequence DP or form 3 from now on. So let's take a classical problem for this one, which is longest common subsequence, right? This is a very, very classical problem that given two strings A and B, you have to find LCS, longest common subsequence of this particular string. So what is the longest common subsequence? A particular string which is subsequence of both the strings and is longest in its length. So in this case, I can think of maybe like G T A B. So GTAB, okay, GTAB seems to be the LCS of these two strings that is given to us, A and B. Okay, so in this case the answer for LCS would be 4. We are interested in length, we can also print the solution if you want, very similar to what we had been doing earlier in printing solutions. But let's first deal with finding the answer, and then we can deal with, like, let's say, printing separately. So now we're given two strings and we need to find out the subsequence in, like, a common subsequence in both of them, which is of longest length. Okay, so that's the problem. So how do we model this up? The way we model this up is we put i's and j's, the levels, level 1, level 2, you can also call it level 1, level 2. So in the first string we put a L1, okay, and in the second string at some place we put an L2, okay, and these things we have decided that maybe they will match across themselves. So when I'm saying match, see, what we are actually interested in is to kind of match characters, right, between two strings, okay, such that the order in the first one remains same with the order in the second one. That's what we are interested in to a certain sense. Okay, so we are at level 1, or let's call this also as I and this as j. Okay, so if you're at I and j, we are left with this much of the strings. The way we will formulate the state, we already know the form, so I'm just jumping down to step 2. The way we will formulate the state is going to be dp of I comma j, right? We don't need any aggregate anymore to kind of match these two things. So I am just going to close it over here, and we're going to return LCS. The question answers longest common subsequence. The longest common subsequence of A of I till N. Okay, let's say this is of N length, and B from J till M. Okay, from I till N and J till M, what is the LCS of these two strings is what we want to calculate at dp of I comma j. Note that LCS is what was asked, but for the whole string. Now with this two levels introduced into two different arrays, we now have a sub problem of that, which is a part of the array or part of the string, whatever is there. Okay. How do we design the transition? That is more interesting in these kind of problems, because once you know I and j, you know that there are two levels that are traversing together. So when we have dp of I comma j, okay, so it means, let's say there is this particular thing, this is at I, okay, this is I, and over here there is a j. Okay. Now multiple things can happen, right? There might be some character over here, some character over here. There can multiple things that can happen. Let's say there is a character, some a, some character b, or let's rename them with some variable x and y. Okay. So note, let's say we are dealing with different cases. Let's say this is the thing that is currently over here, and this is the thing that is currently over here. Now, if this would have been the ideal solution, like whatever we had drawn earlier was the ideal solution, then between these two characters, we are supposed to discard this, right? Because this is not going to get matched with anything in this part. And we can move to this much of the problem, and then we will get the same answer as the previous case. So one possibility that we can do is, okay, maybe, just maybe, whatever the first match that comes up, right? There is going to be some first match in the thing. Maybe it might be between this element and this element, okay? Or it may be between, if not between these things, maybe between this element and this element, or maybe between this element and this element, or maybe the first match that comes up between these two strings is between this element and this element. Neither of the two gets used, right? That is the 4 different cases that can appear. This doesn't get used in the first match, and this is what is used. Note that once this gets matched with this, okay, you cannot match this with something else over here, because then there will be a cross. There will be a crossing between the two edges. And essentially, when you're dealing with subsequences, right, this to this order should be same as this to this order. So there will not be any subsequence anymore. So we cannot match it this way. So either this will get matched over here, or this will get matched over here, right? So let's go back and let's try to kind of simplify this. So let's say you're dealing with this x character in over here, y character over here, and this is the ith index, and this is the jth, and this is the jth index. Okay. Case 1. What if this is going to be the first match with something, possibly some match, right? In that case, we are sure that this is not going to get matched with anything, right? So y is waste. Okay, y is not going to get used in the LCS. This is one possible thing. In that case, we can discard this off, and whatever answer we're gonna get for this much, right, between dp of I comma j plus 1 is what is going to be the best answer in this case as well, right? The other thing that can be is that maybe x is waste. Okay, what if x is waste? In this case, we have j plus 1. Sorry. What if we have this x as waste? In that case, possibly y might be get matched with something over here, right? And this is not going to get matched anywhere. All these characters will be thrown off, because if the first character over here gets matched with this much, this one, nothing over here is going to get matched, right? So we can throw x is waste. Okay. dp of I plus 1, like I will move one step forward. Don't use this x anymore. It's like don't use x, and then we still potentially can use y. Okay, this is what is we are trying to explore. Okay, maybe what is possible is that, okay, not a lot of things can happen with both of them. Then possibly we can also try and keep something like this. dp, sorry, we have this index I, index j, okay, x and y. Potentially both of them are not going to get used, but that will get controlled by this particular transition directly, because first time it will exclude of x, so it will go into this much, and then it will exclude of y, so it will get into this much. So somehow that particular thing is going to get covered up. I'm going to explain that up later again when I'm going to code it up, don't worry. Okay, but one very important property is that what if this is the first character which gets matched? What if x is equal to y? Okay, only when x is equal to y, maybe the first match happens then and there. So what we can do is, this is going to match, so we get one character in the final subsequence. Okay, and whatever is left, now these two characters cannot be used anymore. So I plus 1, j plus 1, this is another possibility. Only if x is equal to y, the first character of the both the strings are same. So these are the three different transitions that are there in this particular case, with the third one having a condition. Rest two are always possible. Let's go back and try to see how it might generate the solution for this. So I'm going to write it over here, a g g t a b, right, and g x t x a t b. So I'm going to show you how this transition that I wrote might try and explore the correct solution. So let's say first we are over here with both the things. It sees this and this, okay, and it decides. So it is going to find out the maximum possible length across all. It's going to find maximum across all. So it will try and explore everything, right? And the best is going to return. What if maybe it explores discarding this? Then it will find out between these two things. It will match these two things. So it will find out. So there is a +1 over here, and it will match between these two things. Now let's continue with a different color. So it doesn't match. So what if we discard, let's say, this one first, or you can even discard this one first. Then you are left with this much, and then you discard this one. Then you are left with this much, and then you match these two characters. So you get another +1, right? Next we kind of go for the forward part, this much, we discard we discard this one, and then we move even further, and then we mismatch this a and a, right? So we will get a +1, and in that case +1 plus go into recursion into the rest of the stuff. So this much is left, discard this one, this much, match these two characters, +1, and you go into like one of the strings get emptied, so we cannot have any other match. So that will be like our base case. When one of the levels reaches the end, we cannot match anymore, so it's going to return 0. So we had added 4, so +4, which is the answer in this case, right? So this is one way in which you can explore the things. What we're interested in is matching the current character if possible, or discard one of them. That's the only option that we have. Discard one of them right now and then try again. That is equivalent to discard both of them, because discard one right now and then discard the other one in the next step, that is equivalent. So we can skip that particular part, that we discard both of them possibility. Okay, so that's almost the whole transition that is going to be used for this LCS DP. Okay, that what do you do with the current first two items? That's the main transition idea for these kind of problems, that when you're at I and j, what do you do with the first two items in the two sequence that is there? Okay, and accordingly there will be transitions. What if it's a match, what if it's not a match, and whatever is asked, according to that we need to do. So this character gets matched and get added to the longest common subsequence, and find the longest common subsequence of the rest of the part. That's what we do. Okay, so that's the kind of transitions for the problem. Let's quickly talk about the time limit as well. So quickly, number of states over here is going to be I and j, n into m, right? I can take n different positions, j can take m different positions. Number of transitions is going to be 2 or 3. Sorry, 3, right? There is going to be 3 different transitions, 1, 2, 3 on the worst case. So the formula we just put in over there, order n m 1 plus 3. By now you have realized, right, that if there is a constant number of transitions, we don't even like change anything. It doesn't change anything, right? So that is something we will also have a kind of setup from now on. So you can get order n into m. So whenever you have multiple sequences and you're trying to think about DP, mostly you are going to cut it at some part and solve it for the rest of the things that is left. And you match the first character directly and then see what is happening with that. Okay. And according to different things that can happen, do you add it in the answer or you don't add it in the answer? You might need to discard one of them and one of the pointers will move forward. That's how form 3 generally works. Okay. So that's the form 3. And let's maybe kind of quickly code this up. The fifth step would be to coding this one. Fifth step would be the coding this one. So let's code this up as well. LCS is fairly like a standard question. So this is something we coded in the last problem. So we're gonna take it. Okay, we're gonna take it this one, and we're gonna write certain things over here. So we're gonna take n m. I'm gonna take since it's string s1 or a b, right? That's what we had taken. We can find out nm using the strings as well. Once we have the strings, we can find out, we need to do a recurrence call. So we need to write the recurrence. So integer recurrence of integer I and integer j. So this is the two different levels in the two different pointers. Now the recurrence is going to return the LCS, longest common subsequence of a of I till last and b of j till last. That's what it's going to return. Note that it's 0 index now. So you're gonna have n minus 1 over here, you're gonna have m minus 1 over here. Okay, that's the thing that you're returning. Now the code is going to remain same. Firstly is pruning, then it's going to be base case, then it's going to be save and compute, then it's going to be, what do you take next? You take the compute part or the transition part, and the next is save and okay. So pruning, do we need any pruning? I don't think we need any pruning for this particular problem, because anyways every state is feasible to be reached, and we can handle things in compute as well. Base case, so base case would be if I is greater than equal to n, which is like if the first one exceeded the length, or j is greater than equal to m. If either of them exceeded the length of their own individual strings, what we're going to do is we're going to return 0, because we can have no further matches, because one of them is now empty, right? So if one of them is empty, LCS between an empty and another string is empty, so we're going to return length 0. Okay, save and compute we'll add later. First we'll compute it up. So answer is equal to 0. One option is that answer is going to be max of answer comma what is the LCS or recurrence from if you discard the A's ith character. If you don't use that in the first matching, that is going to be there immediately present. Okay, so when I'm saying first matching, just understand that we are trying to find out G, T, A, B. We are generating the solution. We are like finding out the solutions in order way, right? So the first match would be G, next match would be T, next match would be A, next match would be B. So we are trying to find out the first match first, so that will add the first +1 to the answer of the common subsequence, and then we will move forward from there. So let's go back to the code once and let's see what we were doing. So over here we had, like, if you discard the first character over here, we're going to get this one, and we can also potentially discard the other character and it's going to remain the same. Like, discarding is always in our option, right? We will not use this. So we are exploring every possibility. Don't think that we are doing it only once. Like, this is what we are doing. We are exploring all possibility like brute force, but we are caching it up and we are saving all these options in the answer, best of them in the answer. Now, if you discard it from the j, then it will go to j plus 1. And if a of I is equal to b of j, if the first character of both of them is same, then the current match can happen then and there. So what we will do is we will also update we will match them. The current character will get added to the LCS, and we are going to go to +1 to both of them because the next characters are going to get matched. So this is how we are like generating the final answer, and we're going to return the answer. This is going to give you the LCS, but it's a brute force right now. It will go into all three options and it will say compute the answer correctly, but it will be exponential in time. In fact, something like 3 to the power n-ish in time. But what we will do in this case is obviously add DP to it. So let's add DP. Let's add, like, let's say 1000 lengths is the maximum that we're dealing with. I mean, extra numbers here and there doesn't really matter as much. Save and compute. If we have saved it, so we can assume that DP is by default memset. DP -1 size of DP, right? Because because in this case the return value is the longest common subsequence, length of the longest common subsequence, and it is always positive or 0. So it is going to be fine if we put it negative. And then we're going to call recurrence. So DP of I comma j is equal to -1, is not equal to -1. If it's already computed, return the saved value. Okay, compute it, and before returning, just I generally copy it from over here itself because that's the state where you save, copy and just make it equal over here. Okay, and then when you are solving the original problem, you're solving it from the start of both the strings. So we see out recurrence of 0, 0. We are starting in both the things. The whole strings are present. Find the LCS. That's the exact question that is there, right? And that will print the whole thing. So that's the LCS of the two string code that you have to find out. Okay. So this is how you write a code of form 3. Like, you have two different strings, two different arrays. There is an I and j level for this one. You have I greater than equal to n, j greater than equal to m. This is the base case. When one of them gets completed, you handle it in a particular way for that problem. Caching things, and that's very, very common for DP. And you handle what happens with the first elements right now. That, like, you only handle what happens with the first elements right now, because the way we have set it up is we can get the matches if we do it this way. Like, we can remove this, get the first match, then remove, and then get the next match, remove, get the next match. So any solution that is possible will be explored in this whole traversal. So we will get the best answer. Only thing is that we can also cache this up and make it very, very less. In terms of the complexity, it will be n into m. Okay. So that's the whole idea for this particular problem. Okay. So we have also coded up now, just in case you want to see the full code once. That's the full code, and this is the main idea. I mean, you guys can code this up now. By this time, I think you have seen writing me DP codes multiple number of times. Let's quickly do one more exercise, okay? Let me add one more thing. Let's say we are finding longest common subsequence of 3 strings A, B, C, okay? And we are given 3 strings A, B, C, and we need to find it out. Now, one very, very obvious thing that you might think about this particular thing is, what if we do it this way, that LCS, longest common subsequence of A, B, C, is equal to LCS of AB. First you find LCS between 2 strings and then take that LCS with the other string. The problem with that is LCS are the longest common subsequences are not unique. The length is unique, but the sequence itself is not unique. There is multiple possible ways in which you can get it. So in this case, G, T, A. So one option between these two, I'm going to write it over here. One option between these two is G, T, A, B, right? Another option I can see is A, like A matches, not exactly, yeah, A matches over here. So another common subsequence over here is A, T, so A, T, B, okay. These are 2 different subsequences, and when you are finding out the longest common subsequence, you will find this one because this is of length 4 and this is of length 3, so you will not use this one. Now, if you take LCS of this one with this one, G, T, A, B, so G, TAB, the best you can do is TB or GB or AB. So you cannot get more than 2 length. If you take LCS of this with this, it will be 2. Whereas if you take this 3 length one, ATB is present. So with this one, the answer would be 3. So to its true sense, the longest common subsequence between the 3 strings is ATB, right? But if you find out the first LCS and then use it, it is not correct because the LCS is not going to give you the answer. So how do we handle this in our code? Okay, how do we do this? And we again like extend this ending form itself. Now there are 3 strings. So what we'll do? We'll do I, we'll do J, we'll do K. Somewhere over here we'll add a K, right? Now let's say there is this final like common subsequence which we are building. We are finally building this. So I'm going to just quickly do it this way. So we are starting over here, here, okay? Let's say we don't, so the way we'll do it is we will explore everything. What if whatever we match and add to the common part, right? There is a common string that is getting created. If the first 3 characters are same, then we can add that to the common string, right? Because we can take it as a match in the 3, but it is not in this case. So the way we can do that is we can discard any one of them. So we can discard this, and we can go to this particular solution space, right? A state. Then we can discard this and go to this state, go to this state, go to this state, discard, and then we can match. First match we can do over here, which will add A. Then we will move forward. We will move to this much, okay? And then we will do discard this, okay? And then we will match over here. We'll add T, and we move forward. Then we go forward, because T has matched, and then we discard this, and then we have this, we match B, and we get a B over here. So ATB, this is how you find the common subsequence. So if there are 3 sequences as well, you can add another level in the 3rd layer and then just solve the problem in a very, very similar way. So in terms of code, that would be very simple. Just add a K over here, integer K over here, and this would be, let's say the C is there, like K till some MNL, something, some length, whatever the length is, NM, some variable. It is very difficult to choose variables these days. And the string is C, NM, and what have we not used? X. Let's take the length. I mean, it's the length of CX, in fact. Okay. And we call it with 0, 0, 0 because we have full strings of all the 3, right? And we will add just this K is greater than equal to X. In that case, we will return 0 because now if any one of the string becomes empty, we cannot match any common, right? Because whatever we take, we have to take as a common from all the 3. Then only it's a common subsequence in all the 3, right? Then we have to obviously add k into the subsequence over here, right, into this one. And then we have to add k over here as an option, k here over an option, and another transition where k gets like this element at the k is going to be removed. And in case this is equal to this and b of j is equal to c of k, right, if the three things are same, in that case we can take that string as a common string and move it to one step forward. So this is how we can do this in this case. And over here we can add in k. At the call we added a 0, so this should be all that is needed for even adding a third string, right? So when you have multiple sequences, you have multiple different levels traversing in them, and you match the first character somehow to get to extract out the answer. If it is not being used in the first match, then you discard. The options are to discard one of them or match all three, right? That's how you do it. And everything that is feasible can be generated through this process. So that's how you write the recurrence transitions, and finally you just mold it into the DP formulation that we have been learning till now. Okay, so that's how form 3 looks like, and this is what like the key idea of form 3 is, that when you have multiple sequences and you need to generally match or compute cost or make them same or whatever you want to do, like there is some relation between the characters you have to match somehow with some cost, with some conversion and stuff like that. It's mostly a form 3 problem, right? So this is the main idea for this particular video, the form 3. We have unlocked it now, and I think you're going to get practice questions on that as well today. Next video we're going to learn form 4. So see you in that particular video. And also, if you have been seeing these videos, definitely like and comment below that whatever things you have, because that is going to motivate me to make more videos like this. Do that. Chalo, see you in the next one. Bye bye.